Hey guys, how you doing? Me? Doing great, just packing. Where am I going? Huh, glad you asked. I'm setting off on a journey toward the nearest black hole. Yep, risky and brave, that's me. But don't worry, I'll keep you in the know by live streaming my entire adventure. So make yourself comfortable and come travel through space with me. Okay, so let me introduce my spaceship. The name of this super fast beauty is the Invincible, and people won't create anything of the kind for the next several decades. The thing is that space distances are seriously long. That's why traveling there would take way more time than you'd like to spend on the road. For example, Voyager 1, a space probe launched in 1977, was traveling out of the solar system at the speed of 40,000 miles per hour. If my spacecraft moved at the same speed, it would take me a whole 77,000 years to get to the nearest star. I mean, really? It would also take me more than a billion years to cross the Milky Way galaxy. But luckily, the Invincible is much faster than that. Also, I almost forgot to introduce my companion. Sorry, Liam. You see, Liam is a robot with AI. You know, artificial intelligence. That's why I have high hopes for him. I'll have someone to talk to during the flight, and he can help me if things get really tough. And now, let the journey begin. Here we go. 3, 2, 1, blast off. Wow, the Earth is growing smaller and smaller by the second. It seems like no time has passed, but our spacecraft is already 200 miles above the surface of our planet. Since it's daytime, I can clearly see the Great Lakes shining in the sun. And oh boy, I've just spotted something moving to the left of my ship. Could it be? Yes, it's the International Space Station. Did you know that the station is the most expensive single object in the world? No wonder with a price tag of $100 billion. This money would buy you 250 Boeing 747s or two Louvres with all the paintings and artwork inside. For my spacecraft, the ISS looks pretty big, but I shouldn't be surprised since the length of the station is over 350 feet, which is more than the length of a football field. But I don't have time to linger. A black hole is calling for me. Now I'm about 1,300 miles over the surface of the planet, and I start to spot satellites here and there. I've read that among satellites, there are low and high flyers. And while the lowest flying ones move approximately 1,250 miles away from Earth, which is the length of 4.5 Grand Canyons, the highest reach 22,000 miles into space, which almost equals the Earth's circumference, measuring about 25,000 miles. By the way, few people know that satellites travel at a blinding speed from 7,000 to 18,000 miles per hour. Also, the higher a satellite is, the slower it moves, relatively speaking. For example, the Weather Tracking GOES system of satellites orbits the Earth once a day at a distance of 22,000 miles above your head and reaches a maximum speed of 7,000 miles per hour. Well, the satellites are being left behind, and my spacecraft has already taken Liam and me toward the moon, about 240,000 miles away from Earth. That's the same distance you would go if you went around our planet 10 times in a row. From here, Earth looks like a small, bright blue ball hanging in the middle of nowhere. And you know what else? From my spacecraft, I can clearly see that the moon isn't a perfect sphere. It's shaped more like, like an egg. Wow. Anyway, bye bye, moon. We're headed somewhere even further. I see Mars, Jupiter, Saturn, and Neptune passing by in all their glory. And look, there's Pluto, who used to be a planet but was later demoted. From here, Earth looks like a small star that's getting fainter and fainter as I'm moving further away. But wait, what's that? Some object is approaching me at a high speed. Could it be Tesla? Whew, that was close. The thing just avoided a collision at the last moment, and everything happened too fast to see it clearly. But I'm pretty sure what I just saw was a Tesla. Right now, I'm already really far from Earth, like 100 astronomical units away. The thing is that space distances are so vast, you can't even calculate them in miles. That's why scientists use the term astronomic unit, which equals 93 million miles, the distance from the Sun to Earth. That means right now I'm 9.3 billion miles away from our planet. But what's happening? Why is my spaceship shaking and rocking so much? I see. We're entering the termination shock, the place where solar winds coming from the sun travel at a speed of 250 miles per second and collide with the material that makes up the galaxy's background. Ah, there. We made it through unscathed. But there's another trial ahead, the Oort cloud. That means two things. First, we're on the outskirts of the solar system, and second, we'll have to get through a cloud of icy objects orbiting the sun at a distance of 100,000 astronomical units. In other words, it's 1.87 light years away from our star. Whew! It must be my lucky day, since we got through the Oort cloud with just a couple of scratches on the spacecraft's skin. And voila! We're heading out of the solar system just 1/10 of a light year later. By the way, if you were trying to reach this point by car, the trip would take you more than 19 million years. And even if you piloted one of the fastest spacecraft that exists nowadays, NASA's New Horizons, you would still need 37,000 years to complete the journey. So bring a big lunch. All right, we've left the borders of the solar system, and now I'm sitting in my spaceship cabin watching comets and asteroids pass by. Time to think about my destination. In the center of pretty much every galaxy, there's a supermassive black hole. For example, one is sitting right at the heart of our Milky Way galaxy, about 27,000 light years away from Earth. But even my ship wouldn't be able to get that far before my 100th birthday. That's why my destination is the stellar black hole nearest to Earth and much smaller in size, but no less mysterious. It's V616 Monocerotis, also known as V616 Mon, located 3,000 light years away and weighing the same as about 9 to 13 of our suns. A black hole is an eerie place where those laws of physics we studied at school stop working. If a massive star runs out of its star fuel, it becomes super dense and buckles under its own weight, collapsing inward and bringing space-time along. As a result, the gravitational field of this new thing gets so strong that nothing can escape it, not even light. Right now, we're approaching the black hole, and very soon I'll send Liam to explore it from the inside. I won't go further than the horizon, also known as the point of no return, and you can probably guess why, right? Once an object crosses this invisible line, it can't turn back, even if it changed its mind. Anyway, Liam says he's ready to start his journey. There he goes, bravely plunging toward the black hole while I'm recording everything that's happening to him. He's accelerating. It looks like he's contorting and stretching, as if I'm looking through a huge magnifying glass. Interestingly, the closer to the horizon he is, the more slowly he seems to move. He's trying to send me encoded light messages like we agreed to in advance, but the light waves stretch to redder and lower frequencies. I'm okay. I'm okay. What's happening? Liam just froze, as if a gigantic finger has pressed a pause button, and now some force is stretching him thinner and thinner. I've read about this phenomenon. It's the infamous spaghettification, which happens in a super strong, non-homogeneous gravitational field. The black hole's gravity force is stronger at his feet than at his head. That's why he's getting stretched out like a piece of spaghetti. Also, the sensors inform me that Liam is getting hotter and hotter, and then nothing. He just disappeared, and I can't see him anymore. But since I did my research before the trip, I know that Liam is in the state of free fall now, and feels no more stretching, scalding radiation, or gravity. Unfortunately, the connection is lost, and he can't tell me anything about the inside of the black hole. This is a moment I didn't think through well enough. Anyway, I hope you're okay out there, my friend, and I think I'll head home to get ready for my next space trip. What about you? Do you think I should go all the way and explore this black hole myself next time? Well, let me know down in the comments. If you learned something new today, then give this video a like and share it with a friend. But hey, don't go getting spaghettified just yet.